Hi, I'm Thom Gibson.
And I'm Patrick Frasier.
And we are both teachers here at the Khabele School. I've been teaching in an inquiry-based learning style of teaching for about the last year and a half. Patrick's been doing something really similar called problem-based learning for over 3 years, I believe. What is problem-based learning and why do you choose to use that?
Problem-based learning is collecting and writing a set of problems that are scaffolded in a certain way so that students can come to their own understanding and work through problems really by themselves. So it removes the teacher from the center of the classroom. I almost never lecture. If I do, it's about a specific problem. But really it takes the power and puts it in the hands of the students instead of just me doing examples and then handing out worksheets. And that's the reason why I started doing it, because whenever I was teaching conventionally with a textbook, I felt like I didn't really get to hear from my students very often, and it was really, honestly, it was just really boring. It wasn't as exciting, and to fall in love with math, you have to really own it, and I felt like I wasn't having that happen in my classroom. And as soon as I started doing problem-based learning, I saw it happen, and I was like, I have to do this.
And we're going to be taking a look at some videos of Patrick kind of doing this style of teaching. In those videos, what kind of problem are we going to see, and why did you pick that problem?
Yeah, so this problem doesn't use any new content. It's just Pythagorean theorem. That's all it is. And they did that months and months ago. But they haven't seen it explicitly in a while, and they haven't seen it used in a problem in this clever kind of way. And they're probably going to look at it and think that they don't know how to do it. But they do, and that's why I chose it. And it's a really fun problem.
Okay, well, let's take a look.
Because
Alright guys, go ahead and have a seat. Alright Kate, so walk us through what you're thinking.
Okay. So, just as a diagram, this is the rope. When it's hanging down to the floor, it just barely reaches the floor. This is it when it's touching the wall. It's 3 inches above the floor, and it's 4 feet from the wall when it's hanging. And I didn't really know where to go from this from here, but I was thinking that you could do something like this. But I couldn't figure out how to find the slope of this line or how to find like this actual triangle. So any help would be really great.
I think I've got it.
Okay.
So your diagram's awesome. I have a suggestion.
Yes.
Whenever you're dealing with things where you're going to be talking about things in inches and then things in feet, just make sure that you're consistent.
Yeah, okay.
So what do you want to change? Do you want to change the 3 to a fraction or the 4 to a 48?
I'll change the 3 to a fraction. Actually, no, I think 48 would just be easier. Okay. Miles, do you want to come up here and grab a marker?
Well, I just thought of this, but if you say that whole side is x, then the height we're looking for is to here, so that's x minus 3.
Okay. So we're looking at your diagram, and the thing that you notice about the isosceles part of it, focus on that.
Okay. So, where am I going with this? Okay, so...
If the height of the wall, if the height of the ceiling is x,
Oh, then it's x minus 3 as well.
what's the hypotenuse, Kate?
The hypotenuse is the same as this side, so then, I don't know.
Well, what's the variable that you used?
We used x for it.
Yeah,
Okay, so
they're
what's the
both
hypotenuse?
x.
Oh, x. Oh. And that would be in inches, and then, do you want to convert it into feet?
If I tell you a ceiling's 382 inches high.
Yeah, okay, we're going to convert it into feet.
Good.
That sounds wise, because it's probably not.
So Robert has another solution.
We already stated that this point had to be the same distance from this point because it's the same rope with the same length. So then we have 2 equations, then it's just a matter of solving them.
I'm just going to write what Robert already wrote, but just bigger right here. So he says, and we know that if this were on a coordinate plane where the corner, the edge of the wall is 0, 0. So the rope would then be at 0, 3 when it's stretched out, and then 48, 0 when it's laying on the ground. This perpendicular bisector would have to go through the anchor point up here, and that's an equation that's easy to find because we have 2 coordinates. What's the perpendicular bisector? So you get this equation, where does it intersect x equals 48? You're good to go.
But then, how does that help you find, like...
Because, why, Robert?
We're solving for the y coordinate, which is how high the ceiling is.
So we're trying to figure out what is the x, y. We know that x is 48, and y is the height.
Oh.
Technically, what was new about this problem?
Nothing.
Like nothing, right? Technically nothing. What did it focus on? Like, what did it develop for you? Harry, what do you think?
For me, like, I realized that you can figure out lots of things even if they seem like much more complicated. Like, it's often like math that you already know. Like,
Yeah, yeah, totally.
Now that we've seen you kind of do it with one class, they did that one problem. What are your notes? What are your reflections on how it went?
Yeah, so that class is super fun in the sense that I can just give them anything and they're kind of okay with it. Like, that doesn't mean that they get it right away, but their attitude is they're really kind of stoked about everything. What happened there kind of met my expectations. I knew that some kids were going to have at least a really accurate drawing that I could just say, hey, that looks good, put that on the board. And then I figured some kid would have something to add and eventually we kind of get there. It took a little bit longer than I expected, and then a student had a different solution that I wasn't expecting at all. I'd seen a solution like it on a similar problem, so I should have maybe anticipated it. But I try to never tell a kid that it's like, no, that's going to take too long. Don't share your cool, like, outside the box solution. So that one problem ended up taking 2-3 times as long as I thought it was going to. But it's totally worth it. And then at the end, I did a reflection with them, and it was like, hey, what's new about this problem? And they were like, nothing. Like, so that was cool that they recognized that they have the ability to solve problems even when they don't initially think they do. I think the common question when people are thinking about doing problem-based learning is, doesn't this only work for high-level achieving students? And that's not necessarily my experience. It might be a little bit easier in the sense that you have to question less, but it works, I think, for any kid that you can engage with. And so with this class, the amount of questions that I have to ask, the amount of teeth that I'm going to have to pull might be a little bit different, but we're still going to get there, and it'll still probably take about the same amount of time, but there might not be the second solution method introduced, and focus on what do you do when you don't know what to do, just kind of like a motto of like both of our classes. So focusing on it more from that perspective so they can just build confidence is really what the goal will be for the class. Yeah.
If you want to reach out to Patrick about anything problem-based learning in any regard, he's at Frasier Math on Twitter, and I believe FrasierMathPBL.com.biz.
.wordpress.
So let him know if you have any questions, and I am also at GibsonEDU on Twitter and here on YouTube.
Cool.
See ya.